So, I'm gonna be solving the exercise of friction motionless of statics. So our problem says a 40 kilogram crate box made of wood is at rest on a level surface if the coefficient of static friction between the crate and the surface is .69, what horizontal force is required to start moving the crate? So let's see our situation. It says there's a crate and it has a mass of 40 kilograms. So with this we can imagine how our free body diagram is gonna be. So it'll be like, here's the weight, here's the force, natural, and the frictional force. And our initial information we had that we have a mass of 40 kilograms. But in this case, we don't want to work with that. We want to see the weight. And for that, we'll need that weight is mass times gravity. Our weight is 40 kilograms times our gravity, which is 9.8 meters per second. So that means our weight is gonna be 392 newtons. So we're good for now. And our other initial information, we have that there's a coefficient of static friction of 69. And in this case, we want to see what horizontal force is required to start moving the crate. The other things we have is the force on y, it's going to be 0, just like times the force on x, it's going to be 0. Why is this happening? Because our key takeaway or our key points says that the first condition that the net force on the object must be 0 for the object to be in equilibrium. This means if the net force is 0, then the force along any direction is 0. So in our initial information we have that y it's newtons and weight. So we have our natural force minus the weight equals to 0. So this means that if we move the weight to the opposite side, we have that normal force equals to weight. And as we have our weight already, this means that our natural force, it's gonna be 392 newtons, you see? Because we have it here as an initial information already. So in the case of force on x, it's gonna be force minus the frictional force. This means force minus the frictional force, it's gonna be 0. And force is our one of the initial information we have, and the force is the data we want to get, because that's what the problem says, what force is required to start moving the crate. So in this case, force minus the frictional force can also be divided by natural force times the static friction equals 0. So if we substitute the values we already have, we had a natural force is 392 newtons times our coefficient static friction, which is 0.69 equals to 0. If we solve this multiplication, we're gonna have 270.98 equals to 0. And just as we did in this step, we substitute the value to the right side, we pass it, and we have that our force is going to be 270.98 newtons. So that was kind of simple. So what is our general information we need to remember? The force in both sides, in y or x, it's going to be the 0, because the condition says that the net force of the object must be 0 for the object to be in equilibrium. And when we have mass in the problem, when it says the mass, we have to convert it on weights. It's gonna be times weight equals mass times gravity. And just what we did in these two steps, we only substitute the values. So that's it for now.